I give you one more example. And here we're having the differential equation y double dash plus minus 4y dash plus 4y is equal to e to power x over x. So here you can see this is 1 upon x is not the polynomial function. So we can't apply undetermined coefficient here. We have to use here variation of parameter. Part 1 is same. We first find the homogeneous part because we need the solution y is equal to yc plus yp. Yc is same as we did in the case of homogeneous equation. Yp is different. For yc, we take here the homogeneous part of the differential equation. Now we say here we use the substitution. Let y is equal to e to power mx, and you substitute this, we get the characteristic equation. We get characteristic equation, and that is our m square minus 4m plus 4 equal to 0. Factorize this one, we get here m minus 2 into m minus 2 is equal to 0. We get here two roots, m equal to 2 and m equal to repeated roots. My roots are repeated, we write over y. My y is yc, c1 e to power 2x plus c2, as the root is repeated, multiplied by x, x2 e to power 2x. So this is my yc, this is my part 1. Now for part 2, we are going to use our method, that is our variation of parameter for part 2. So this is my part 2. We want to find yp. So yp is equal to u1 y1. My u1 is, we found y1 is e to power 2x. That's here u1 e to power 2x plus u2 x e to power 2x. What I need? I need y1, y2, f of x. So my y1 is equal to e to power 2x. My y2 is equal to x e to power 2x. I have my f of x. My f of x is equal to e to power 2x over x. I want to find w. What's my w? My w is equal to e to power 2x, x e to power 2x. We solve it. We get here 2 e to power 2x, and solving this one, we can take the derivative of this is 2x e to power 2x plus e to power 2x. Now we simplify this one. We'll get here, multiplying these two, we'll get here the result is equal to 2x e to power 4x plus e to power 4x multiplied by e to power 2x. Now here is minus sign, minus 4 minus 2 2x e to power 4x. So e to power 2x is cancelled e to power 2x. We get here the result is equal to e to power 4x. That's my w, and this must not be equal to 0. It's never 0. So we say we can apply the Cramer rule. So as the Cramer rule, we are having here, this is u is equal to u1 dash. This is my u1 dash. u1 dash is equal to minus w1 over w, and u2 dash is equal to w2 over w. What's our w1? Our w1 is equal to, we just replace the first column by here w1 is equal to 0 f of x, and then here is y2 dash x e to power 2x, y2 dash is 2x e to power 2x plus e to power 2x. Then here this is 0, and get here minus x. And what's my f of x? I put the value of f of x. My f of x is e to power 2x over x. So we get here e to power 2x over x into x e to power 2x. Then x is cancelled with the x, and we get here minus e to power 4x. So this is my w1. We find here w2. So my w2 is equal to, I have here y dash, and then I have 0 f of x, this is e to power 2x over x. We solve this one. We get here e to power 4x over x, because here this is giving me the 0 contribution. We are having the only contribution due to this. This is same as we say here y2 f of x. This is y2, and this is f of x with minus sign. And this is y1 f of x. This is y1 f of x. Same as we have discussed there. Now we write our u1 dash. My u1 dash is equal to W1 over W. What's my W1? My W1 is minus e to power 4x. What's my W? Is e to power 4x. We get here minus 1. And now we're having here U2 dash. U2 dash is W2 over W. What's my W2? My W2 is equal to here e to power 4x over x over W, that's e to power 4x. So we can write this one as e to power 4x over x into 1 upon e to power 4x. E to power 4x cancel e to power 4x, we get here 1 upon x. Very easy, we can find u1. Integrating this one both the sides, we get here u1 is equal to integral minus sine d of x is equal to minus x. u2 is equal to integral 1 upon x dx, and this is my ln of x. So I can write my yp. I have u1, u2. I put the value of yp here. I put the value of u1 and u2 here. What is u1? u1 is minus x. So we get here minus x e to power 2x. Then my u2 is ln of x. I put it to the end. We get here plus x e to power 2x into ln of x. So it's my yp. I have y1. So I combine this one. My general solution is y is equal to yc plus yp. So I can write this one. My yc is c1 e to power 2x. My y2 is c2x e to power 2x. This is my yc. My yp is minus x e to power 2x plus x e to power 2x into ln of x. This is my yp and this is my solution. I make a quick revision of this solution with you. We have the differential equation, and this is my f of x. This is not the category that we can apply undetermined coefficient, but this way is the same. We find the homogeneous part of the solution. We get here two roots, m equal to 2, m equal to 2, roots are repeated. When roots are repeated, we multiply by the x. So they are linearly independent. We have yc c1 e to power 2x plus this x is coming because the roots are repeated. And we give the example that we're having one solution and we have the differential equation of second order. We can find the second solution by the formula, and there we see that we are having the multiple of x. So we apply that one. Then we number two, we apply the method, that's our variation of parameter, that we could write here. This is y equal to u1 y1 plus u2 y2. This is my method to find yp. I have the value of y1, y2, one find u1 and u2. So here we have y1 is e to power 2x, y2 is x e to power 2x, f of x is e to power 2x. For f of x, we must see this coefficient must be 1. If this is not 1, then make it 1. This coefficient must be 1, and here we can say our x is not equal to 0, because when x is equal to 0, this is not defined, become infinity. So we are having now, this is my f of x, we are having w is y1, y2, y1 dash, y2 dash, solve it, we get e to power 4x. w1, this is 0 f of x, y2, y2 dash, solve it, this will be 0, and this here with the minus sign, we get minus e to power 2x over x, x is cancelled x, we get e to power 4x. y2, this is y1, y1 dash, this is 0 f of x, simplify this one, we get here multiplying this one with plus sign, that's e to power 4x over x, and this is giving me 0. Now we can have here u1, that's u1 is w1 over w, u2 is w2 over w. We can solve with the help of this one, as I did in the example 1, or with the help of this one, as I'm doing in this example. So we get here u1 dash is equal to minus 1, u2 dash is equal to e to power 4x over x over e to power 4x. Cancel, we get 1 upon x. This is my value for the integration. We integrate, we get here u1 is equal to integral dx minus 1 minus x, u2 is 1 upon x dx, ln of x. Then substitute the values of u1 and u2 to find yp. This is my u1, this is my u2, and this gives me yp, and then we can write here yc plus yp, and that's my solution. So we give you one more example.